So we're going to continue with 8.10 series and parallel circuits. First thing we're going to talk about is combined resistance of resistors in series. Now, for example, here R1 3 ohm and R2 6 ohm. So how I'm gonna find the full resistance is simply by the sum for both of them. So R, it's R1 plus R2. That means R is 3 plus 6 ohm, and that's give us 9 ohm. Moving along, combine resistance and resistors in parallel. So here now, for resistance, it's 1 over whole R, or that's equal 1 over R1 plus 1 over R2. Or, we have this way, it was just for two resistance. So, important, this way, just for what? Two resistance. Not more. This way, we can use it for 2 and above. 3, 4, 10, etc. So what we're doing here, applying the example, 1 over R, it's equal 1 over 3, it's equal, plus, as you can see here, 1 over 6. So we're gonna make them together, multiply this 2 over R is equal 2 over 6 plus 1 over 6 is equal 3 over 6, 1 R. That gives us R is equal to ohm. Okay? This is just for this way. Now let's do the other way here. So they say you should multiply them, then we divide them on the sum. So let's try also. R is equal 3 multiply 6 over 3 plus 6. So 3 multiply 6 is what? Is 18. 3 plus 6 is 9, and that gives us 2 ohm. So R is what? 2 ohm. Sorry. So find out in the both ways, this one or that one, they give us, of course, the same results. But again, this one just for what? Just for two resistors, not more. Let's clear this up. So you can see in your book, page 191. There's examples. We're going to take example now. So for the series here, we find that combined resistance is what? The sum of them, or we just R1 plus R2, simple. And here, even we use this way, or multiply them, we divide them on the sum of them. So we say it again, but then this just for two resistors, not more. This I can use here. For example, I have here another resistor, R3. I can put plus 1 over R3 and do the same thing we do here. So open your books, page 191. Gonna solve the example together. Example 1. Calculate the potential difference across the 3 ohm resistor and 6 ohm resistor in the circuits on the right. So here's the circuit on the right. We have battery, have 18 volt, and we have here 2 resistors, R1, let's say R2. The first one have 3 ohm, and the second one have 9 ohm. So they told us they want what? The potential difference across each one. That's mean here, how much is the volt, and also here, how much is the volt. For first, we need to find what? The current. Remember this? Don't forget it. So, if we want the current, that means the potential difference on what? If I want this, V over R, or V divided R. So I have the V, it's what? 18 volt, so and R is what? I have 2 R's, that means R is equal to R1 plus R2 equal 3 plus 6 equal 9 ohm. Okay? I have here 18 volt on the R. I just switch out 9 ohm and it's equal 2 ampere. Now after I have the current and I have the total resistors and I already have the volt. So now as we know, the current in the circuit I, it's all the same. Why? Can you tell me why? Because it's what? It's series circuit. So the current will be the same. So let's go back here. We have R, we have the current, it's 2 ampere, and we need the volt. So if we need the volt, that means we multiply the current by the resistance. So volt 1 for the VD, potential difference. Let me write for you so you won't confuse. Potential difference for the first resistor here, it's I, the current, multiply what? The resistor. So I multiply R1 and it's equal 2 multiply 3 ohm and it's equal 6 volt. Okay, so this is R1. First reading here is what? 6 volt. And with the second reading, for the 6 ohm, potential difference 2 is equal to I, R2 multiply, it's equal to 2 multiply 6, that gives us what? 12 volt. So this 12 volt. So how I can now make sure that my answer was correct? So I pull up the first potential difference and the second potential difference. So that means 6 volt and 12 volt, and they should be as the battery. So VD, the battery is what? PD1 plus PD2, PD equal potential difference is 6 volt plus 12 volt, and that's equal 18 volt. That's mean what? It's the same thing. And we solve this example. So let's take another example for other circuits. I'll keep this because you always will use it. Always. In this kind of circuits, this as the saying say, your hand and left. Okay. Now you see the example 2, so we together, we have a battery and two resistors on parallel. Okay, so first resistor 3 ohm, R1, R2 6 ohm. The voltage is 18 as the last time, and here now we have what? More than current. Good. And the volt here is the same. Why? Because it's parallel, and in series we say the volt will be different. So the current here will be different. So if we have example here, we have I, the full I, then we divide to 2 at this joint, I1 and I2. So read the example. Example 2. Calculate the currents I1 and I2 in the circuit on the right. So I have to find I and I1 and I2. How am I gonna solve all of that? So first of all, they give us what? The resistor. We come back to our law. Current is what? Volt resistor. So I want the first current. For example, I1. So I1 is what? The volt. Here now, we focus at that parallel what we say. The volt is always the same. So here is 18 volt. Here is 18 volt. Here is 18 volt. Okay? Resistance 3 ohm. So I1 is what? I need the I, it's V over R. V over R1. That's equal 18 volt over 3 ohm. That gives us 6 ampere. This is I1. Now I2, the same. Volt, the same. It's 18 volt over R2. 18 volt over 6 ohm. That gives us 3 ampere. Now after I found I2 and I1, I need what? I. So I is what? It's the sum of I1 plus I2. So that means 6 ampere plus 3 ampere, and that gives us 9 ampere. So as you saw, it's simple and easy. Just focus on what? On this pyramid or the triangle. Everything you need, just cover it and do the math. That was our video today. I hope you enjoy it and keep yourself safe. Don't forget to wear your mask. See you next lesson. Take care.